Okay, so welcome everyone. I welcome you all to the very first coding based session of this particular course. Okay, so in this we'll understand what is NumPy and why do we actually need NumPy. Okay, so NumPy is a Python library which is designed specifically to work with NumPy arrays, or basically with numerical data in Python more efficiently as compared to traditional Python. Okay, so what do I mean by more efficiently? I know that is a very obvious question and a doubt. Okay, I have got the same doubt when I was reading about it. So as we do, we learn everything by first understanding whether there is a requirement to even learn that or not. Okay, so let's first discuss the need for NumPy. So let's get started. I hope you're excited because I'm very much excited. Okay, to teach you this amazing world of NumPy. So first we are talking about NumPy, and within that we are first understanding the need. Okay, so I will call it Python, or I should say Python loops versus NumPy arrays, or Python lists versus NumPy array. Better. Okay, Python lists versus NumPy array. So NumPy array is exactly same as a list. Okay, those who have done programming in other languages, there we call it as array, here we call it as list. The major difference is that in array we can store every element of the same data type, but in case of list, as you know, Python list can store heterogeneous data. It can store a string, integer, float, everything at once. But in case of array, we can only store one data type at a time. Okay, and this is the reason NumPy arrays are way much more faster as compared to Python lists, because they are stored in a very different manner. Okay, and this is the backstory about it. But from the programmer perspective, let's understand why do we say that NumPy is better than pandas. Okay, sorry, why do we say NumPy is better than Python lists? Okay, so let's take an example. Okay, suppose I have a list. Okay, so let's say range 1 comma 1 2 3 4 5 6 10 lakh numbers. Okay, 1 to 10 lakh. Okay, good enough data? I would say still a small data as compared to what we work in industry. And n equals to length of a. Okay, so let's print n. Okay, so 1 to 10,000, 10 lakh minus 1 is 999. Okay, perfect. So we're having this much of data. Okay, now let's say I give you a simple task. Okay, first let me print the first 5 numbers of this list. So a, how do we do that? Go back to your Python basic courses, okay, that we have taught. Amazing, that we have gone through. And this is how you can check the first 5 elements. Okay, 1 to 5. Perfect. Now suppose the task is that you have to add 5, okay, or any number to every element of this array or of this list. Okay, so the task is add 5 or any value for that matter to every element of the list. Okay, now let's do this by approach 1, which is using Python lists. Okay, so a is a Python list. You can check type of a, it's a Python list. Okay, so what we can do is we can loop over this list, and we can keep adding every element by 5. Okay, so I will say for every element in a, or give me a second, for I in range n, because I want to modify the element, a of 5 plus equals to 5. Simple, I'm adding 5 to every element. Okay, now because I want to tell you whether it is efficient or not, I would actually store the time, and this is not actually that mandatory, but just for your learning experience. Okay, so I will say start equals to time dot time. Okay, and let me import time. So import time. Okay, so basically what we are doing, we are actually storing the starting time and the ending time. So the time before this operation started running, and after this operation has ended. Okay, so I will say end equals to time dot time. Okay, so what is the duration? What is the duration? Correct, difference between both. So print duration using Python lists equals to simply end minus start. Okay, and these many units of time. So let's see. Okay, so 0.21 or 0.22 units for that matter, 0.22 units of time. Okay, perfect, fair enough. You will say AJ 0.22 is still so less. I agree on that. Okay, but let's see the magic of NumPy. So approach to using NumPy arrays. Okay, again we don't have NumPy lists. NumPy array will store every element of same data type, and that's why we call it NumPy arrays. Okay, array. Perfect. So first, again, I'll be teaching you all the stuff, but this is just for your motivation purpose. So I'll directly use something called a function using which we can convert a list to a NumPy array. Okay, and that is np.array. Okay, that is np.array. But before you even do that, you have to import NumPy. Remember the modules and the packages lecture from your Python course? Same thing. Okay, so I'll say import NumPy as np. Now this is going to be your bread and butter throughout in this course. Okay, so actually by standard approach we put it as the first line in the notebook, but for you I am writing it here. Okay, and I'll say a1 equals to np.array a. Okay, so creating NumPy array from a list. Okay, and if you check type of a1, you will get np or numpy.nd array, n dimensional array. You will understand what is this in some time. Okay, the only point that I'm trying to tell you is that I have created a NumPy array. That's it. Okay, now let's do the same task, but in NumPy array you have something called vectorization. Now you will not understand what do I mean by vectorization. It is one specific chapter moving forward in this course, but basically you can perform element wise operation in NumPy array. Okay, so basically what I can do is I can say start equals to time dot time, and I will say a1 equals to a1 plus 5. That's it. I know it sounds funny, but that's it. Okay, so a1 equals to a1 plus 5. Okay, if you want, I know that it can be a bit shocking, but if you want, I can show you the first 5 elements in the NumPy array. Okay, it is 6 7 8 9 10. Okay, give me a second. Sorry, wait, let me rerun this. Okay, it is give me a second. Oh, okay, we have modified a, right? So let me rerun this code. Okay, because we have already modified a, right? So let's run this. I'm glad that we have checked. Okay, so 1 2 3 4 5. Now I am doing a1 equals to a1 plus 5. I know that you might be thinking like, are you literally adding an integer to a list or an array? The answer is yes. That's what NumPy is. Okay, and I will say end equals to time dot time dot time. Okay, and then let me copy this to save some time. Copy. Okay, so this is your major operation, and here I will say duration using NumPy arrays. Now I hope that you are super duper ready to see the magic. Okay, and let's run this. 0.0068 units. In Python, the same task was taking 0.22 units, and this is 0.0068 units, almost 1000 times lesser, hundreds, or I should say, yeah, 100. Okay, almost 1000 times lesser. Okay, if you divide it by 1000, if you divide it by 100, you will get this, right? Almost 100 times lesser. 100 times. Okay, imagine that you are working with a very large data set. Okay, then what will happen? Think about it. So this is the basic idea why we say that NumPy library is specifically designed to work with numerical data efficiently in Python. I hope that this motivates you to learn so many amazing concepts in NumPy that are coming across this course as part of a very, very systematic and step-by-step modules. Thank you.